Welcome everyone. Thank you for joining us for today's expert webinar titled Docker Compose and Multi-Container Applications. I am Abhishek from Spring People. We are India's largest enterprise training provider. I will be your moderator for today's session. In today's session, we have global certified Docker expert, Mr. Syed Mudassir. He is a seasoned expert in delivering comprehensive training programs with a hands-on approach focusing on global certification standards. Mr. Mudassir is experienced in various technologies like Docker, DCA, Kubernetes, Ansible, Terraform, CKA, CKAD, CKS, KCNA, Containerd, Podman, Cloud Computing, OpenShift, Helm, Shell Scripting, to name a few. In today's webinar, Syed Mudassir will let us know about managing multi-container applications with Docker Compose, Docker Compose syntax, and configuration. To all the participants, you can mention your questions in the chat box and it will be answered at the end of the session. Without further ado, let's start today's session. Now I would like to invite Mr. Syed Mudassir to start the session. Over to you, Syed Mudassir.
Thank you so much, Abhishek. Just quickly confirming, can you hear me okay?
Yes, we can.
And see my screen okay as well?
Yes, it's visible.
Awesome. Thank you so much. Thank you for your kind introduction. Hello, everyone. Welcome to today's webinar. We're going to look at a tool called as Docker Compose, and we're going to understand how it is going to make our life easier when it comes to deploying and running multi-container Docker-based applications. Let me just, what is the overview agenda going to be? We'll try to understand why we really need a tool like Docker Compose. And then we try to understand a little bit of overview of the history of how Docker Compose evolved. How does it help us? We will look at few features and use cases, and I will demonstrate to you of how to deploy a multi-container based application using Docker Compose as a tool. And we will try to dissect a little bit about how a compose file looks like. We try to understand a little bit of syntax and semantics of that as well. Let me get started without further ado. Now, before I get started with Docker Compose, let's take a step back and try to understand our microservices world. Traditionally, the way we know the applications which were deployed and run earlier were monolith in nature. When I say monolith, the whole of the application would be built, tested, deployed, and run as a single unit. Right. Then came the virtualization era, where we broke down the monolith application into multi-tiers. And then now is the era of microservices-based application, where a same monolith, a big block of application, is broken down into smaller chunks of application, containerized and deployed and run as single units. There are, of course, many benefits of doing so. You get this granularity, you get the scalability, you get the fault tolerance, and then that's how we've been containerizing our applications, breaking down them from a larger chunk into smaller mini applications of their own and deploying them. Here is one example of an application, maybe an online boutique, an e-commerce website maybe, which we have broken down. We've taken and broken it down into multiple smaller services. For an end user to have a very nice experience, all of these services needs to be deployed together, run together, and that's when the end user has a seamless interaction with our application. In the example, what you see on the screen, we have taken the microservices demo, which is a very famous demo of an online boutique store, where we have many smaller application chunks, each deployed as its own container. Say, for example, if I give you more clarity or breakup of different services we have a front-end app which is exposed on a server to our end users may be built using a Golang running as its own container. And then we have card service, we have currency, we have payment, we have email, different services, different applications on their own, mini applications built using different language stacks, deployed and run as containers. Together, they interact with each other, and you have a meaningful application for yourself. Now, this is our microservices world, right? Now, if we want to deploy and run this application for the end user to make use of our application, we want to deploy together, right? So that is where a little bit of complexity comes into picture, where we have a simple application like these with services like front end, card, currency, payment, getting all of these working together, and then is when you will have a useful application, right? Deploying and managing a lot of these small microservices can be hard. Why do I say so? Well, what do I need? I have, in this example here, I have, say, 11 different microservices, right? Each one running as a container on its own. So in short, if I have to start and deploy this application out there, what do I need? I need 11 Docker files. Let me just spin out a notepad real quick. A minimum of 11 Docker files to, of course, to run the container, I need the images. So for the images, I need Docker files, at least 11 Docker files for each service. And I would maybe need to make use of commands like Docker image build. I need to build these images before I can deploy and run them as container. That's the basic prerequisite, right? And then I need to go ahead and deploy these containers on my machine. How do we do so? Well, with simple commands like Docker container run, for example. Again, I need to run 11 of these Docker container run commands so that these containers can be deployed. And we also know that containers are ephemeral in nature. There are scenarios where I want to persist the data, the transient nature of it. Maybe I want to have my backend database running out there. I want to persist the data. Well, as an average, if I need 11 volumes. So if I need to run 11 Docker volume commands, for example, before I can deploy my application, I need to run these commands to set up the volumes. Of course, we don't want all of the microservices or all the outside world to be talking to our containers. We want to provide an isolation layer for them. Maybe I will run one Docker network command, create a separate network for my containers and deploy my application. Now, I want my database container to be deployed first. Then I want my front end to be deployed. Of course, having the front end exposed to the outside world where my other services are not up yet is not a good thing. So I would maybe formulate a way in which I would deploy all of them. Keeping it simple, to deploy this application example, what we saw, we need to maybe run around 40 to 50 different Docker commands so that this application can be deployed and run successfully on our machine. Now, you see, it was a simple example of a simple application, what we wanted to deploy. But suddenly we realized when we have too many small microservices, it can be hard managing it. Well, what do I mean? Well, for example, if I want to start this application, maybe I need to run 50 or 10 Docker start commands. If I want to restart some service, I need to run 10 different restart commands. If I want to stop it, if I want to see the logs, the complexity increases when the number of microservices increases. That's where a tool like Docker Compose comes into picture, right? So that was the problem statement. And well, when you have a lot of small microservices, like the example what we saw, deploying and managing an end-to-end multi-container application becomes the problem. So what is the solution? We don't like to do things manually. We don't want to run 50, 100 odd commands manually. So what can we do? Well, in the beginning, Compose was not part of the Docker suite, right? Docker engine comes with your API and other things. Docker Compose was an external tool. In the beginning, if I take a couple of years step back, like if we go back 4 to 5 years, there was a tool called as Fig. Fig was a tool which was created by a company called as Orchard, right? and it was one of the best way to manage the multi-container Docker applications. It was a Python tool which sat on top of Docker, which let you to define your entire multi-container application in a single YAML file, where you could then deploy and manage the end-to-end lifecycle of your application with simple commands like Fig command line tool. In fact, the tool was so great, Docker had an eye on it. They acquired Orchard and they rebranded or renamed the tool as Docker Compose, and that's how we have Docker Compose. So how does Docker Compose help us, right? So what we do here is, instead of writing a script maybe to start these containers one after the other, instead of writing maybe some scripts to build these images for us, we don't do any of those. We take a YAML file, a configuration file, which Docker Compose as a tool understands, and we define our entire multi-services, multi-container application as different services in it. What do I need? How should my container look and feel like? When you go back and run Docker container, there are 100 options maybe you can specify, like what port number to use, what command to run, which volume to make use of, to run as a which user, what should be the restart policies, and so on and so forth. I don't need to script any of those. I don't need to write long and lengthy commands. Instead, in the YAML file, I define how my application should look and feel like. We call this as a desired state of how my application should look like, what Docker file it should make use of to build the image. And when the image is built, how should the container run? What network it should make use of, which volume it should mount and where. We can define everything in this file, and we can make use of a simple command like docker compose up. That's one of the command where you can just specify docker compose up. And what does docker compose do? It'll do all the work for you. It'll go take a look at the compose file. It'll build the image for you. It'll create those networks for you. It'll create those volumes for you. It'll deploy the containers and bring your application up and running. That is what your Docker Compose as a tool does. So how do we do that? Simple Docker Compose YAML file. You write all of your application, define your Docker files, and just run the command like Docker Compose up, and it runs the whole application for you. It gives you a rich set of tools for monitoring, for introspection, just like the way we did Docker Compose up. We could just do Docker Compose down to shut down the whole application. Or you want to look at the logs of these microservices, you don't need to run 10 different commands. You can just say Docker Compose logs. It's going to go show you the logs of all your services. It gives you many such tools or many such options when you run and deploy your application that way. What I'm going to do is I'm going to demonstrate to you of how it looks like, because me speaking over the slide would not add any fun to it. Let me go ahead and show you how we can deploy our applications, and I'll show you. We will make use of many examples out there, and we will try to see how we can deploy our application. Now, before we get there, uh, let's look at few of the features. It helps you deploy your end-to-end application, right? But Docker Compose as a tool works while you are deploying your application on a single Docker host. Now you might ask me, where is that helpful? We don't run single host, right? We don't, of course we don't. But there are in development regions, in your testing regions, your development environments where you want to deploy and run your multi-container application and start testing them. You make use of tools like Docker Compose. When it comes to tools, when you have multi servers involved, we make use of clusters. That's when the other tools comes into picture, for example, Stack or Kubernetes, for example. But when it comes to standalone Docker host, Docker Compose is the tool what we make use of to deploy and run our applications. To name a few features, it helps you preserve your volume when your containers are created. You don't need to worry about deploying the failed containers. You don't need to deploy all of them. Well, if you make use of Compose, you can just selectively restart whatever the failed containers are. You can recreate only things what you have changed. Of course, from one version to another version, you are rolling forward. I don't need to bring the whole application stack down. I can change what has been modified. And with a simple command like Docker Compose up or Docker Compose restart, I can just restart what those application containers have been changed. These are few features. The most common use cases of Docker Compose, like I was mentioning, is in the development environments where you want to maybe automate your testing environments. Well, you want the application to be deployed, a set of tests to be done, and then the application needs to be cleaned up. We can do Docker Compose up, the whole application is deployed, run your automated test builds, and you say Docker Compose down, the application is cleaned up, and you have your results. That's where the most common uses of the tool Docker Compose, mostly used in the single host deployments and development environments, and mostly in the testing environments. Let me show you an example of how a compose YAML file looks like. What we see on the screen is a very simple example. When we demonstrate, I'm going to show you a little bit of complicated ones as well. What we see on the screen here is services as one of the upper level domain in the compose file. Under that, we have two child called as web and Redis. That is where we have defined two different containers, two different applications, how they need to be run. So under the web service, I've mentioned, there is a Docker file in the current context which says build. So go read that Docker file. Dot in the Linux world is the current context, current folder. So it's going to read your current folder. It's going to pick up the Docker file for you, and it's going to build that Docker file for you and deploy that image, what has been created as a container. While doing so, I'm asking it to make use of some ports, attaching some volume as bind mounts, and deploying and running it. Let me do one thing. Let me demonstrate so that it will be uh, a better example than showing you this YAML file. Let's see it in working. I'm going to bring out my server real quick. I have Docker installed on this. Well, installing Docker is very easy, very simple. For those who don't know how to, if you have a machine, all you need to do is if you just go to Google and say get Docker, there's Docker engine and Docker desktop as well. So if you just do get Docker, it gives you a script like this, get docker.sh. That's exactly what I have run. Takes a minute or two, and you set up with Docker. Right. So this Docker Compose tool used to be an external tool. Like I was mentioning you earlier, it was a tool called as Fig, which Docker bought that company, Orchard, and rebranded or renamed it as Docker-Compose. It was not part of the initial installations earlier. So you had to install this tool separately on top of Docker engine, just like the way we would do Fig back in the days. But now what has happened, it's been incorporated with the Docker engine itself, the Docker suite, whatever CLIs it comes with, CLIs and APIs. So Docker Compose, you need not install it separately. You install Docker maybe using a script like get docker.sh. Docker Compose also gets installed. So right now on my machine right now, what you see, I already have Docker installed. So Docker space compose is the tool name. If I hit enter, it shows you the options what you have. Scroll back up a little bit. It tells you, gives you the usage. You can just say Docker compose and specify what options if you want. Here are the options. What commands you want. Here are the commands. Right. Let me show you one simple example. Let's go to Docker Hub. Let me quickly bring out my browser. Let's go to hub.docker.com. There's a very popular application called as Ghost Blog. Let's search for that. I'm going to make use of this. It's a free and open source blogging platform written in JavaScript, pretty popular as well. So if I scroll down below to this, it gives me a Docker Compose file as well. So if you look at the file, there are a few options here. Let me simply copy this. A simple example though. I'm going to show you the complicated ones in a while. I'm going to create a folder. Now let's understand this YAML file a little bit. Typically, generally, now the versions have changed a little bit. If you look at the screen, we have few top level resources. On top of the compose file, we find something called as version. The version key used to be mandatory. It used to be always the first line at the root of your compose file. Basically, this defined the version of the compose file format, the API. You should normally use latest. In the latest version, this key is not mandatory. If you take away this line in your compose file, it still works fine. It chooses the latest option. But if you are a little older versions of Docker, this used to be a mandatory line. And next top level key, what you have is services. Here is where do you define the different application microservices you have. In this example, we are defining two services. I have a Ghost front end and, and a database called as MySQL as two different services. Now, what does Compose do? Compose will deploy each of this service as its own container. Now, let's try to understand a little bit of what the options we have specified here. Say, for example, if I had to run this application, just as a standalone Docker command, what would I do? Well, I had to run the command maybe skip you. Let me just copy it back once again. I'm sorry. So if I had to deploy this application myself as just as a container, I would do it this way. I would write my Docker command. I would say Docker container run. I would maybe name my container, say hyphen hyphen name, whatever the application may be, Ghost. Then what would I do? I want the restart policy to be as always. So I would mention restart as always, right? I want to make use of a port. I want to map this port on my host to be mapped onto my host machine. So I would make use of small p, and I would say maybe 8080 on the container, 2368 on the host, then hyphen hyphen env. I would specify all these different key value pairs, what you see here, key colon value, right? I would mention different keys and values, and then I would maybe mention the image name, that is what we make use of here. So what I'm trying to just explain is however you would deploy and run your application, exactly the same way is what we define in your YAML file. Like what name you want, what restart policies, what port numbers, what volumes, what keys, all of those thousand or hundreds of exam options you want to specify, you mention all of them as is in your compose file. Let me open the compose file one more time. So that is what you find under services. In our example, we have two microservices we have defined, and how should this one container be built is the example here. How should be the second container be run is exactly similar, like Docker container run hyphen hyphen restart is equal to always hyphen hyphen image, the name of the image, and env, all of that. Now, instead of me writing multiple commands, what have I done is I have defined them as a configuration file. Now, apart from these two top level key resources, what you see here, there are also other top level resources, like for example, volumes. You can define volumes and then define what type of volumes you want, what should be the driver Docker you wanted to make use of, what are the options you want to specify for those drivers. You can specify all of those examples here. And you can also specify the another fourth top level resource is network. You can define what kind of networks you want. You want an overlay network? Is it attachable? What should be the driver? What should be the IPAM? What should be the bridge? All the options this way. So you define your whole application stack in a YAML file, which serves as a source control for you, which works as an which you can check into your source code repository. You know how the application was deployed. You can always go back and check on it. Acts as like a version control. And all you need to do right now is save this file and just make use of a command like docker compose up, and voila, your application is deployed. Let me go ahead and deploy this application and show you how it works. Now we have defined a simple example of ghost blocks is what I have taken. Has two different services in a as we're not building the image, we are using the image what is available in Docker Hub for this example. Once we're done with the example, we'll go back and look at furthermore example where we build as well. All right. So all I need to do right now is do Docker compose up. That's all I got to do. I don't want the containers to be up and running in the foreground mode. I'll just specify the option as -d so it runs in detached mode. Let me hit enter. And you see both of my microservices are right now getting deployed. The Docker is pulling a DB layer and DB service, an image, and a ghost image. Let's give it a minute or two. The image is a little larger. I didn't anticipate it to take so much time. Otherwise, I would have pulled that image already. Be with me for a minute. There you go. The images were pulled. A default network was created. Well, the security aspects behind the scene is when you deploy and run your containers, they by default connect to the network called as Docker 0, a bridge network, which any container which runs on your machine connects to it. Well, we don't want our application microservices to be talking to the whole world. So what does Docker Compose do? I did not define a network. Well, it made use of a default driver that is bridge, and it created a separate network for us. That's where my containers would be attached to. I did not define any volumes. If I had done, it would have created those volumes for me as well. It pulled the images, it created those containers, it created the network, and started my application. My application is deployed right now. I can make use of Docker Compose, say maybe ls. It shows me there's an application which is running, it has two services, and here's the config file, what it made use of. Right? You can say Docker Compose PS, maybe, for example. It shows you what those containers are. What are the names of those containers? What is the image it's making use of? A little bit of story about that. What port? When was it started? Right? Similarly, I can just say Docker Compose and ask for help, and it shows me a bunch of things I could do. I want to look at the logs. Fair enough. I can do Docker Compose logs, and it's going to show me logs of the containers of all of the microservices in my application right now. For the demonstration purpose, I chose an application we just had two different containers right now. Imagine if we had 11, 20, 100. Instead of you running hundreds of commands, one simple command, you will find the logs of all your application microservices, makes your life easy while troubleshooting. For example, you want to see which is the top consuming process, you can just run Docker Compose top. And of course, you want to stop, you want to restart, plenty of options out there, which will help you in deploying and running your multi-container applications. I'm not going to go through all the application, all the options. You'll see a few of them like restart here, stop and start. You can pause the services if you want to. You can unpause, pause kind of freezes it. If you want to, pluck one service away and do something you want to do, you can just pause that service. Similar, you have multiple options. And if I want to say maybe shut it down, all I need to do is Docker Compose. Okay, before even I shut down, maybe uh, let's try to see if we can access this application, what's been deployed. Right, it is, let me make use of, that's my public IP. Let me try to access that real quick. I'm going to put this in the chat for you, just if you want to access the application. Here's the URL. This is the same. This is the application what we deployed, which is running as a container. It's a simple application out there though, running as a container on my machine. And that's what we deployed. Right. All we did was Docker Compose and up. Same way I can just do Docker Compose and down. What is it going to do? It's going to do the cleanup for me. It's going to remove the network. It's going to remove those containers. Of course, leave those images and the volumes as it is, but clean up everything else and come out. Right? This was one of the simple example. Now let's look at a little bit of uh, more not complex, I would say, better example as such is there is an awesome Compose repository managed by Docker, right? Let's say a Docker compose awesome repo. There's a repository which has example of a lot of applications. Why am I showing you this? Well, if you want to practice, if you want to take a look at how uh, how to write different type of compose YAML files, this is a very nice place to look at. It's a curated list of Docker compose samples. Let me clone this repository and let me show you a better example. Awesome compose is that repository what we have. We have plenty of examples in this, right? Let me choose maybe an example of Nginx Flask and MySQL, just some random example. If I cd into this folder, and if you look at, there is this compose YAML file out here. Let me open this compose file. They have three different microservices defined in this. Under services, they have DB as one service, you have backend as another service, and then they have proxy as another service. So three different things are getting three different microservices, three different containers. What are they doing? Well, in the first example in the DB here, they've directly mentioned the image name, right? So it's going to go to Docker Hub and fetch this image for you. And how should this container run? Like Docker container run. This is the image name. This is the command what I want it to run. This is the restart policy. This is the health check. This is the secret. This is the volume I want to mount. Here is the network what I want you to create. Here are the ports which I want you to expose. So all of that about your container you have defined in this YAML file. Similar, you have another service called as backend here. What's going on with backend here? If you see, we have not mentioned the image name. Instead, we have told the context. We said, hey, in this particular project folder where you are, if you go take a look at it, there is a folder called as backend, which has the Docker file and everything what the Docker file needs to build this application. Let's go take a look at it then. So if I cd into a folder called as backend, what do I find? I find everything what my application Docker file would need. There's a Docker file here. If I open the Docker file, well, it shows how the application should be built, right? So what Docker Compose is going to do, it's going to make use of this build context. It's going to build that image for you. Then it's going to make use of the image, what it is built, deploy that as a container. How, here is the options, how I want it to run. It also gives you few features like depends on. Now this backend depends on another service called as DB, which we have defined on top. We don't want our backend or our backend service to be deployed and be up and running before the DB service has been deployed. So it also gives you features like depends on, where it gives you a little conditional flexibility where you can choose which application container goes in first. My DB is up and running first. That's when my front end comes into picture. Similar, you have another service called as proxy. We are telling, all right, if you go into, there's a folder called as a proxy. That's where I have a Docker file. Please make use of that and build the image. Once the image is built, this is how I want you to create and run this container. I want this container to be connected to the particular network. Again, in the volumes, we have defined volumes here. You see it right below. We've just mentioned the name of the volume. What will it do? It makes use of the default driver. Default driver is the local driver. It's going to make use of a default driver and it's going to create that volume for you. Well, if you wanted to specify different options, you can. Like for example, I want to make use of a S3 bucket. Specify the driver name under volumes, specify the options for that particular driver, and it's going to create that for you. Similarly, we also see networks here. Again, under the networks, we've just given the names of the network in this example. If you wanted a different options under the network, you would define it. Since it is not defined, what does Docker Engine do? It's going to look at all the defaults. The default for network is the bridge network. It's going to make use of the bridge network and it's going to build it for us. Let me go ahead and run this for you. Now we have the Docker files where it needs to be. Here are the folders. There's a folder called as proxy, which has a Docker file for my proxy service. Backend has the Docker file for backend service, and I have the compose YAML file in a place where Docker is going to look like. If all I need to do is Docker compose up, by default the containers run in the foreground. Let's do -d. The DB we had specified as the image name, so it's pulling that from Docker Hub or whichever repository. Default is Docker Hub. That's what it is doing right now. And what do we see? For the backend, we had specified where it needs to go and build it. This is your build process. It's building the image for me as well, right? These are different steps of the Docker build process. It's referring to the Docker file which was present in the backend folder and making use of that. It is executing the steps to build the image. Once that image is built, it's going to make use of that image to create and run that particular container. And that image is built, and it did the same thing for the proxy as well. If you see here, proxy container also, it went and right from here built that particular image using the build process, and then it created the networks what we had asked for, and then it created the volume what we had asked for. It created and started our containers. So you define your entire multi-container application, and you just do Docker compose up. So if you do Docker compose PS, right now it shows you all of these containers and gives you all that example. Of course, we make use of my public IP and try the port 8000, you would be able to access that application, what has been deployed on my host right now. All right, so this is one of the example I wanted to show you about the Docker Compose. The awesome Compose repository is pretty cool. It has examples of various different applications. It's a curated list of I think 35 to 40 odd different applications, what you can see on my screen. Has all the compose files in it, has different ways and methods of running. But at keeping it simple, there are only 4 top level services out there. There's version key, there's services where you define your entire application microservices under that, their networks and their volumes. Define it, keep that your compose file checked into your source repository, check out that particular file and run a simple command like docker compose up, and it deploys your application. That makes it easy for managing your multi-container application. When I started off, I showed you an example of a microservices-based application like a online boutique, which had 11 different services. Imagine if you had to deploy all of that on your own, you had to run 50 or 60 odd commands like Docker build the images, run the containers, create the networks, create the volumes. You don't have to worry. Download that YAML file and just run the compose up command, and it's going to take care of everything. Well, I'm done with what I had to do and I need to shut down. All you need to do is docker compose down. It's going to destroy what it created as well. It's going to stop and remove those containers, networks, and get out of there. That's how simple to manage a multi-container based applications lifecycle using the tool like Compose. All right, so I have given you the reference to the awesome Compose repository, where I would, if you are interested, you can clone that repo and go through it and try to deploy various different applications. I'm not going to do that for now in the interest of time. I just want to demonstrate that and show you how cool that is. Going back to our slides, the demonstration is what I did. And Abhishek.
Thank you, Syed Mulasir, for your invaluable insights on technology. I'm sure it was certainly a very informative session for all of you. If you guys are interested in learning more about various Docker, do check out our super discounted batches of virtual instructor-led trainings on our website, springpeople.com. These VILT trainings are leveraged online from the comforts of your home and flexible as per your schedule and location. If you do not find any suitable batches, we would be happy to discuss and schedule private batches for you. If you don't have time to join live online, then do try out our affordable self-paced courses. For more information, do write to us at training@springpeople.com or call on our number displayed on the current slide. Now, we will open the forum to answer questions that we have received during the session. So let's get our questions answered. Over to you, Mr. Mudassir.
Thank you so much. Let me take a look at some interesting questions out there. Very nice. How does Docker Compose is compared to uh, the Kubernetes? All right, nice question, Samad. Now, how is Compose different than Kubernetes is the question, if I understand correctly, right? So Compose is a standalone tool, a tool what we'll make use of to deploy and manage the lifecycle of a multi-container application on a standalone Docker host. Like you have a single deployment of Docker host, like for example, your development environment, your testing regions, where you do not have multiple servers. Single server, like you are the developer working on it, you need to deploy that application, run your test, do your development, do your coding. That is where you make use of a tool like Compose, which will help save your time, increase your productivity. 50 commands versus one command, hit enter, your application's deployed. We saw that in the demonstration, right? But when it comes to the Kubernetes, well, Kubernetes is an orchestration tool. It's a completely different tool, right? When you have multiple Docker hosts, say maybe I have 10 different Docker servers, I want to use that as one single unit, like cluster, right? I want to deploy and run my applications on that many hosts where I have additional other sets of problem, like I have 10 different servers now. Where do I deploy? And if something goes wrong, how do I monitor? If something fails, how do I recreate? I do not want to do any of those. Instead, what do we do is we make use of tool like Kubernetes, which is an orchestration tool, which will help deploy, manage, monitor your application spread across multiple servers. Compose to manage your application on one server, Kubernetes to manage all of your applications deployed across multiple servers. As a cluster, it works as that. So two different tools, two different use cases though. One is for standalone machines, one is for managing your multi-container applications across the cluster. All right. How the logs are saved from the question is a nice question from Naveen. It says how logs are saved from different containers in same place. Well, it does not explicitly. It does not. Right. So where does the logs go then? Well, logs go wherever you have defined in your Docker daemon configurations. By default, where the logs goes, they go whatever is streamed onto your terminal of your container, they go onto the read-write layer, the thin read-write layer, what you get usually under warlib docker and a hash value of the container in a JSON file format, right? That's the default behavior. But if you have configured some logging tools, so if you go and do Docker info, it shows you there are many different plugins already available with Docker Engine, like Fluentd, you have Splunk, you have AWS logs and stuff like that. So if you had configured that, of course, it'll go where it is configured. What I was trying to explain when I was telling about Compose was, if I want to go look at logs of 10 different containers, well, I need to run 10 different log commands, right? Container one, container two. Instead, when I do Docker container logs, it's going to read where the logs are. In my case, I had left it default, so it all went to the read-write layer, and it would bring out those logs from that particular place and show it to you all using one simple command. All right, I hope I've answered that question. How can we automate? How can you use automated testing with Docker Compose? Good question. Now, generally, what I mean when you can automate your testing is you have your automated test scripts which you want to run against your environment. Right? So for that to work, you need to build your environment. That's where you go and run your automated tests. So for that, what you do is you incorporate Docker Compose before your automated tests as well. So that brings up the environment for you. You run your automated testing, and then you'd say Docker Compose down. It shuts down, cleans up, and gets out. So that's how it helps you in automate. It sets up the environment so you can do your testing, and it cleans up and comes out when you're done with it. I hope I have answered the question. Um, in Docker Compose, there's number of containers which contain different web services to run it all together. We use Docker Compose. Is that right? Yes. the different webs, different services, yes, different microservices which you want to run as individual containers. So you have defined everything under a main property called a service. Under the services key, you have child properties like different microservices, different containers defined. When you say compose up, each one of the service will be deployed as a container on its own. That's what it does. For developing mobile and Android, Docker Compose will be useful in any ways. Well, I mean, it's a yes or no kind of a question. What Docker Compose does, it helps you manage the application lifecycle, deploying, running, keeping it up and running, checking the logs, stopping it, looking at the top processes, troubleshooting, monitoring. But it does not help you per se in writing your code or writing your Docker files, any of those. It's a tool used for deploying your microservices on a standalone host. Right? Cool. There's some more question. Somebody has posted a long Docker file, which is jumbled. I'm sorry, I can't read that. Sorry about that, Satish. I can't understand your Docker file because it's all jumbled all over the place. Send me an email and I will see if I can respond to you easily. Great session. Can you suggest how can I learn more? Provide some resources. Well, like Abhishek was mentioning, thank you for your kind words. You said it's a great session. Thank you so much. Like Abhishek was mentioning, we have regular batches. You can sign up for them. Now that's that's my marketing pitch, right? And we have very nice trainers, very experienced trainers. You wouldn't find them anywhere else. So that's one way I would suggest to learn. Well, before you get to our class, and if you want to read up on your own, my suggestion would be the official documentations. So if you go to Docker Docs, it provides you little laborious. They are very voluminous for you to read through, skim through all of them, but they provide as a very good source to get started with. I would definitely suggest that, and then I would definitely suggest you contact us and sign up on one of our courses. Right. Thank you. How to set up CI/CD pipeline in Azure DevOps? Well, that's a different topic altogether, Dia. Uh, that's pretty easy, though. It's not that complicated. We also have a Azure DevOps seminar coming up in future. In few days, do look out for, do subscribe to our LinkedIn channels, and you would find the updates on that. All right. I would not. I'm sorry, I wouldn't be able to deep dive into that question because it's off topic a little bit. The next question is it possible to deploy multiple different applications in single container? Well, technically you can, but the whole point of breaking down my application and making it to smaller containers is to get the benefit of microservices, right? Like I said, technically you can, but it is not why we have containers for. It is for decoupling and breaking down the larger chunk into the smaller chunks. So we should avoid going back to the root. When you go back to the microservices root, you break it down and you deploy as a container on its own. But I also understand your container. Is there a possibility where I can merge both of them? For some odd reason you want to deploy, you can, but you don't leverage the benefits of containers. You don't get the benefit of the scalability, the resilience, the fault tolerance, and all of that. But if you really want to do, yes, you can. There's something called as multi-service containers. You can look it up. You can Google it on that multi-service containers. There's a config tool or config file comes like as a supervisord.conf. So you configure multiple processes or multiple applications into that file and run this as an entry point, and you can. Right? All right, the next question, can you please explain links in the Docker Compose? Yes, the links are that depends on and things like that, which will link from one service to another service. Right? That's what it is. Next question is there can be many containers in a service, but whether can we get the logs for each? Yes, you can. You can. Right? How do I do that? Well, Docker Compose logs and you do options on it, like say hyphen help. It tells you. You specify the service name. It just lists that particular service for you. If not, it lists everything for you, right? What? That's the good question again. Another question is what is the difference between Docker Compose and Docker Swarm? Very nice. Docker Swarm is a native orchestration tool from Docker. It's another orchestration tool like Kubernetes. Like when you have multiple servers, I want all of them to work as a single unit, as a single cluster. I don't want to log into multiple different servers, and I don't want to deploy my applications on my own. I join all of them together, and I tell my control plane, my Swarm, hey, this is the application, go ahead and deploy. It'll take care of deploying that. Swarm comes into picture when you have multiple servers joined together to run as one unit. Compose comes into picture when you have one server and you have multi-services based application to deploy your application on it. Now, if I'm making use of Docker Swarm, can I make use of Docker Compose? Can be an additional question there. Unfortunately, no, you can't make use of Docker Compose, but there's a tool called as Docker Stack. Docker Stack works for Swarm mode. So if you're running Docker in the Swarm mode, you don't make use of Compose, you make use of Stack. Now, is it something new I need to learn? No, the syntax and everything of the Compose file remains the same, but the tool what you make use of is called a Stack, which will get the work done for you. Right? That's the difference. Another question is, what if Docker Compose server gets down? Do we have backups? Well, dear, that's where when the fault tolerance comes into picture, when high availability comes into picture, we don't run single host, right? We run multiple hosts. That's where we make use of tools like Swarm, Kubernetes to manage all of them. Compose is not the tool for that. Compose is the tool just for deploying and running your application. So if a single server goes down, will all my containers go down? Of course they will. That's why I said it's development or testing regions, not productions. We don't run single host in productions. Of course, I have seen in the earlier days where we had single host servers which would host your productions as well, but not anymore. Off late in last 3-4 years, I haven't seen any production server deployed as a single server on that. Right. Thank you. The next another question is, does Kubernetes use Docker Compose to scale up or down or has its own configuration mechanism based on traffic parameters? Very nice question. Well, Kubernetes dear is a completely different tool, right? It makes use of containerd, or in other words, Docker, to spin up and run your containers. But Kubernetes has its own configuration. Kubernetes has something called as uh, Cube Controller Manager, which is another component of your control plane, which runs various different microcontrollers which run as an infinite watch loop and keep an eye on your applications. If you want to scale up or down, you create those controllers. One of them is called as HPA. Like if you ask me a question based on traffic or other parameters, you can define that. It's up to you. So we call it as horizontal pod autoscaler. You configure the autoscaler and you forget about it. Kubernetes has controllers. Kube controller as a manager keeps an eye on that parameter and scales up and down. It does not make use of Compose. It has its own configuration called as controller manager. All right. Then what do I have? If I have a group of microservices, what if I want to deploy one service? Well, you can. Instead of all services, I want to define few of them. You can. When you say Docker Compose and an app and you do an hyphen help on it, it tells you. If you mention the service name, like if I want to stop one particular service, you can say Docker Compose stop and specify the service name. You want to restart particular service, you can specify the service name. If you don't, it reads the configuration files and restarts or stops or starts all of them. Correct? What if Compose file grow big? How to manage that? Well, that's a that's a trick question, right? Depends on your microservices, dear. Say if you have a lot of microservices, well, there's a problem of plenty as well, right? If you look at the anti-patterns of microservices deployment as well, I really don't want to break down everything into very tiny chunks where managing that becomes a problem for me. I have seen applications with 30 or 40 odd different services, and that's manageable in a Compose file. If it goes beyond that, well, you got to make use of some IDEs, maybe which will help you. Maybe uh, Visual Studio might help you in viewing and taking a look at those files though. All right. Then another question, good question, Abhishek. Bonish, what is if a container crashes due to any reason? In that condition, is Docker Compose creates it again automatically, or it requires manual intervention? Very good question. Now that is where what do we make use of? We make use of an option called as restart policy. You might have looked at the demonstration. You see most of the services we had an option called as hyphen restart. Always was the story. right? By default, if a container crashes, the default Docker behavior is it does not do anything. It'll ask you to go take a look at it. But if I make use of a restart policy as always, it dies. The Docker daemon restarts that container for me. Compose has no role to play there. It's how you have run your container is what defines if it should be restarted automatically or not, and that policy is restart policy. All right. Hope I've answered the question. Moving on. So how to resolve it? If one container has issues, how to resolve it? Well, you need to debug that particular container idea, right? You need to debug that container and you need to look at it. Best way of looking at it is to begin with the logs, gives you a picture, or you can just make use of Docker copy and copy the whole root file system onto your host and go look at the logs file yourself, or you can do a exec and get inside and figure out the different ways of troubleshooting, but Compose will not help you do that. It is you who will have to do that. All right, moving on. Thanks a lot for the information and the awareness you brought regarding Docker Compose. Thank you for your kind words, Venkat. How to use Docker in GitLab CI/CD somewhere? Well, like I was mentioning earlier, we do have another upcoming webinar on the CI/CD aspects of it. We will take up that when we get there. All right. There's one more question from Ishwa. It says, can you explain the network modes in Docker Compose? Very nice. So like I was mentioning, there are 4 top-level key resources, starting with version, which used to be mandatory. It's taken away right now. Services where we define volumes and network, right? So when I want to create a network for myself, what do I do? Like forget Decompose for now. I go back onto my host. I'll say Docker network create, and I specify the options. Let me quickly show you what I mean. We say Docker network help tells you an option called as create. All right, I want a network of my own. Let me do this. Docker network create. What do I see? Well, these are the options you get. Default. We know there was a driver called as bridge. Host none is what we have default. For example, if I do Docker info, this is what we shows me here. Different drivers are available for me here. These are the ones which are installed by default. Of course, making use of Docker plugin command, you can add more network plugins available out there. Now, making use of network create command, what will you do? When you create a network, you specify the options, the name of the network, what driver you want to make use of, what should be the gateway, right? This is how you do it when you create your network manually. Now, coming back to the compose file, let me open the compose file if I have it here. You define the networks. You see right here at the end, we have just defined the network and named the network. But if I wanted to make use of the 50 odd different options I had, all I had to do is, hit an enter key here, add a hyphen, and I specify what driver. Like for example, hyphen driver is equal colon space overlay. And for example, attachable true. I want a different IPAM. I say hyphen IPAM driver as something else. I can say I want subnet as something else, right? I can define all of that just like the way you would do that when you write your command on your command line. You define all of that under the networks in the format, just like the way you have defined your services here. This is where you have defined how your container should look like and feel like. Here are the 50 odd different container options you specified. Same way in the key value format here, you would specify the network options as well. Hope I've answered the question. Moving back. Can you please explain network more, different types of application, different is Kubernetes overcame Docker Compose? Yes and no, dear. I would say no because Kubernetes has a different use case because it is used on running multiple hosts. Compose definitely has a different use case. Like in the development region, in my own laptop, in my testing regions, I don't run multiple clusters, so Kubernetes does not come into picture there. Compose comes into picture. When it comes to production and other places where I am running multiple servers, Kubernetes comes into picture. All right. So 2 different tools for 2 different scenarios. The question is Docker Compose support auto scalability, load balancing, like Kubernetes? No, absolutely no, it does not. So what do I do then? Well, on a standalone host, only one server I have, but I want all of these features. You need to run that particular host in the swarm mode, then it will. But Compose has nothing to do with any of those. All right. And it says, please unmute me is what someone says. I can't do that. I don't have the rights. Another question is whether we can migrate from one Docker file to another Docker file. Whether we can migrate from one Docker file. I don't get that question, dear. I'm not sure what you're trying to tell. Can we create one container from another? I'm not sure what the question is. I'm going to skip that, Kartika. Can we containerize a monolith application? Yes, of course. That's what the world has been doing. How? Well, microservices.io is the starting point I would refer you to. There are different ways uh, of different approaches, different patterns, how you can, like a domain driven approach or application driven, you can break down your application and try to do that. All right. So the question from each were nice, lot of plenty of nice questions. I really like that. When I restart the machine, will it automatically start the multi-containers? Well, again, when your Docker daemon goes down, your machine goes down, Compose has no role to play there. Who has the role to play? Well, the way you asked your Docker daemon to start the containers is the one. The restart policy, what we're speaking about, that is going to come into picture. Default behavior, no, is the restart policy. It doesn't do anything. But if you have mentioned always as the restart policy, when you restart your machine, it will automatically fix that. All right. Can we keep Docker in private state with the security key? I really don't understand what type of security container will. Can we keep Docker in a private state with the security key? I'm sorry, Nikhil, I don't quite get that question. I'm going to move on to the next one. What type of security is provided to our deployed code? Very nice. So, well, so if you look at writing your Docker file, plays a big important part. I don't want my code to be out there. Absolutely. We don't put our code in our images. Yep. So there is a concept called as multi-state Docker build. We'll put our code initially in the Docker file. Maybe we reference, hey, this is where the code is. Go build it. For example, I'm using a Golang. I copy my source code, say app.go, and I say go build app.go. And it's going to generate an executable for me, app, right? And what do? I remove the code. I don't need the code. I need just the executable. And that's what we put in the image. And when you create and run that as a container, the container does not contain my code. It contains only the object code, the executables out there. And of course, there are plenty of security best practices where you don't allow anybody to get inside your container by making them immutable, by making them read only, by changing the configuration files, from taking the shells away from your container. If you just hit the Google on Docker file best practices, you find top 20 of them. So that's how security itself, dear, is a 4-day course what we teach. So there are plenty ways of securing it. That's what we do. All right. All right, moving on to the last question. How can we manage application configuration changes in the container? Is it managed in the container or in the image? So the changes what's been made to your application, that meaning the changes have been made to your images, right? So if you make use of a CI/CD pipelines, when you push the changes, the images are built and those are deployed and containers will be restarted. A new container will be deployed, like not with the compose per se. General concept is when you do perform a rollouts, you modify your images, not your running containers. Yeah, right. If you make changes in these containers, we'll lose the change on the container stop right. So how can we manage that? So we don't make changes to the containers, dear, because when we stop the container, the whatever is there in the memory gets cleaned up, but whatever is there on the read write layer still remains, right? Uh, so so technically, when you stop it, you don't lose it. When you delete it is when you lose it. But we don't make changes to the containers, and if you want to persist, you make use of. We don't do that. Thumb rule is we don't do that. We make changes to the image and we redeploy the container. For some reason, you have a container, you have modified it, and that is the state what you want. If you lose the container, you're going to lose all the changes what you have made. That's where we make use of a tool called as Docker commit. It's not tool an option to a Docker CLI command. Commit, and you create an image out of it. It commits whatever there in the container as a read-only image, and you make use of that image to spin out more containers here. Awesome. One more last questions. That's techniques to decrease the Docker images, yes, dear. The multi-state builds. See, the whole story around security is reducing your attack surface. Smaller the packages, the binaries you have, the lesser they have, lesser the attack surface it is. So multi-state Docker builds and other security best practices are there to reduce the image sizes. Like technically speaking, image size reduction is really not the concern because we don't really care about the storage per se. The whole focus is on security where we reduce the attack surface. We don't give the attacker the surface so we can be attacked. That brings us to the end of the questions. Thank you so much for those beautiful questions. I really like them. Very nice questions. Thank you.
Thank you, everyone. We appreciate you being here. We shall be sending out the webinar recording to all you participants soon. I request you to kindly provide the feedback before signing off, which will help us improve the quality of our future events. Thanks again for joining us today. Signing off on behalf of Team Spring People. Hope to see you again for our next expert webinar. Bye. Thank you.
Thank you, everyone. Have a good evening.